Day 2 of 1-5. Basically, once we're done with this, it's not that zeros go away forever because they're still important. But basically, this is about as far as I can go in, basically, I just give you a function and say, go find the zeros. I could easily let you use the graphing calculators on that, but I want you to do it by hand to show that you can. Because it is a skill you will need if you plan on going on to school. Being able to manipulate some of the stuff. So how many zeros will example 1 have? 3. And I'm basically asking you to find all of them. So does that mean stop if they're not nice, things like that? No, unfortunately not. That means just keep on trying. Now I could just blindly try any number in the world. That would be a horrible choice because you could be there all day. So what you try and do first is you do the crisscross to try and at least narrow down your choices. And I noticed quite a few of you did try Descartes' rule of signs to try and maybe narrow it down even more. But remember that Descartes is talking about all zeros, not necessarily just the rational ones. Okay, you got to see where this is talking about. So the factors here, I think we did these yesterday, right? I think on the last problem we had. I feel like I'm missing one. Right, and then over here it's just 1. And then to get all of them, you basically, we kind of cheat a little bit. We just say that. Now it's up to you. We can do Descartes' rule of signs if you would like, if you think it will help. Would you like to? Okay. Because it might help, but I think you saw one on your worksheet where it actually kind of leads you down the wrong road. It makes you look for a negative, and then there's none that work. Remember, that might be like negative square root of 3 or something. You don't know. So let's see. Well, 1, 2. Do you agree with that? Okay. So it's 2 or 0. Negatives. 1. And then 0, 2. I think we've seen that one before, huh? That's a pretty popular one. So this is, once again, one that kind of leads us to look towards which numbers? The negatives. Now, again, you could just try all those negatives and substitute them in, but really, I got to find them all now. Not just the rational ones. I got to find them all. So it's probably best to go ahead and use synthetic. The reason you want to use synthetic division when you do this is because then it'll tell you what's left over. And then you can just work with what's left over. Because let's face it, when I find one, it's going to be x squared. And again, we spent 2 months working on that in Algebra 2. So let's just kind of divvy up some of the negatives, right? Descartes kind of leads us that way. Again, no promise that it's going to work. But I think, again, negative 10 and negative 20, we can kind of rule those out. There's no guarantee they don't work, but I wouldn't try them first, all right? So let's just kind of invert things a little bit here. We'll have this row over to my left, try negative 1. The second row here, try negative 2, negative 4 right here, negative 5, and then this row, just try whichever number you want. Because we don't really want to try negative 10 and 20. We're just going to kind of say that it doesn't work. So, just kind of divvy up some numbers over there in that group. Okay. And I don't have a problem if you kind of do this on the assignments. If you're working together with somebody, kind of divide them up. But you have to trust who you're working with. Because if they try one that actually works and they tell you it doesn't, that could be a problem. Okay. Negative 1, what'd you find out? Okay, negative 1 is a no, so we'll make a note, no. Negative 2, what'd you find out? Oh, hey, well, let's go do that then. Negative 2. So you're telling me there's going to be a 0 down there, huh? Okay, let's find out. So 1, negative 2, what, negative 6, 12, 10, oh, negative 20, looks good. So now we know for a fact that's done then, right? Again, it didn't have to be there, but it happened that it was, so let's not even look for any more. So sorry, negative 4, negative 5, and all of you. I hope you found out it didn't work. All right, good. Because if you did, we'd have some problems. So we know negative 2 for a fact works, but we know there are 3. But let's face it, right down here, if it was x to the third, this is now x squared minus 6x plus 10. So we can look solely at that now. Is it okay for me to erase these possibles over here now? You've kind of seen them. Good. Can you erase it? All right. It is possible some of those still go in there, but if you're down to x squared, go to your other methods. I always like to try key number first just to find out. You know, it seems to go pretty fast for me. Multiply to be 10. Remember, it's these multiplied together. And add to be negative 6. Do such rational numbers exist? Because basically every time the numbers do exist, it's just they might not be nice. Okay. So yeah, that's not working out, is it? Okay. What that means is you have to go to the method that you know always works in quadratic, and that is quadratic formula. You are guaranteed it's going to work. And here, right there is A, right there is B, and right there is C. Now be careful. A lot of people mess up with this very first move here. In the formula, it says to take the opposite of B should be the first thing you do, right? What is B, though? Right now it's negative 6, right? And so it's the opposite of negative 6. So it's a positive 6. Very good. Plus or minus the square root of negative 6 squared minus 4 times A times C. All divided by. Some people only divide the radical by 2A, but it's everything gets divided by 2A. And A is nicely just 1. Okay, has everybody had a chance to get the synthetic written down that wanted to? So that I can erase it so we have some more room? Everybody have this blue here taken care of? Yeah, okay. I'll leave the answer so that we don't forget that actually is one of the answers. But so we'll move up here. 6 plus or minus square root. Well, now I got to work on this. Well, what is negative 6 squared? We're at this step right here. 36. Now here is a spot for people to mess up. I think I told you that in advance. I told you that in algebra 2. I like to just figure out what that number is and then write it down. Take a negative 4 times a positive 1 times a positive 10, and you get a negative 40, correct? Some people throw extra negatives in there and get things really messed up. So take your time and do that, right? All over 2. Any disagreements so far with what I've come up with? No? In fact, it looks like a lot of you are done already, so I should get moving here. So in here is a square root of negative 4 all over 2. Agreed? Okay. Well, what's the square root of negative 4 again? What is that again? Square root of negative 4. Well, it's square root of negative 1, square root of 4. Square root of negative 1 is? Square root of 4 is 2. So we write it as 2i. So 6 plus or minus 2i all over 2. Now here's once again a spot where I've seen a lot of people do all this work so perfectly, and then they simplify this part wrong. There are basically 3 locations. 1, 2, 3. The same number has to come out of all 3 locations for you to do this. And do you have one number that actually can go into the 6, the 2, and the 2? Yeah, a 2 can go into all of them, right? So if I divide this by 2, it becomes a 1. Divide that by 2, it becomes a 1. And divide that, it becomes a 3. So it's 3 plus or minus I, all divided by 1, or you can just write it that way. So how about Descartes' rule of signs? Did one of the 2 options happen? Yeah, the second one. Okay. Now, that's one of the nice things about Descartes' rule of signs. It better be up there. Once you get done, what happened for you better be an option. Okay? We found all 3. And the reason I know these are all zeros is there's no x in them, right? There's no x minus this or x plus that. Those are zeros. If you have x minus something or x plus something, that's a factor. Okay? There's a difference there. Okay? Any questions on that one? So x to the 3rd is nice, really. You got to find 1, and you're down to x squared, and you got all these other ways of solving it, right? Well, you might notice the next example is x to the 4th, which means I've got to find 4. Now, one thing I can't do is I can't give you one of those problems where all 4 are imaginary. You don't know how to solve that, right? I have to at least get you down to x squared, right? So think about that logically. Are those other problems out there? Yes, but I can't really give them to you because you don't know how to solve them. So you better have at least 2 rationals so you can get it down to x squared to find the imaginaries, right? Think logically about things sometimes. What can teachers do? What can I do with these problems? And what can I do? So, well, let's go ahead and try and find some possibles then. Well, once again, that's just a 1. I've been pretty nice about that on a lot of the assignments. So over here, what do we got? A 1, a 2, a 3, a 4, a 6, and a 12, right? Would you like Descartes or no? Well, it never really hurts, right? It may not help, but... So, no, yes, no, yes. So, and I got a feeling this one's not going to help all that much at all. Now this one, not helping at all, is it? So how about we just don't write that one then? Because it's really not going to lead us anywhere in particular, because we could have 2 positive, we could have 2 negative, but who knows, right? So that doesn't say don't try particular numbers. So we'll get rid of that. Once again, we're probably not going to try 6 and 12 unless we're really getting desperate towards the end there and we need something. All right, so let's divvy these up again and kind of try. All right, let's start the other way here. This row, why don't you try positive 1? This row right here, try negative 1. Positive 2. Negative 2. And positive 3. All right? Well, let's see how you did. I divvied those up a little bit to try and speed things up. What did I give this one over here? I gave you positive 1. What'd you find out? Oh, it works. Oh, that's awesome. We'll do that one right away. So 1. So we got 1, a 2, a 2, a negative 11. Well, that doesn't look very good. But then we got a negative 11, negative 12, negative 12, 0. So we found one of them. Am I down to x squared yet? Unfortunately, I'm only down to, this is actually x to the third and so forth and so on, right? So my suggestion to you is if you find another one that you know is going to work, just take it out of here. Don't try and take it out of the original, because our goal is to get to x squared. And if I keep taking everything out of x to the fourth, am I ever going to get to x squared? No, you're always going to get to x to the third every time. All right? And what if these are imaginary? Okay, what if they're radicals? You're never going to get anywhere. So take them out of this one here, that's x to the third. So I'll do that over here. I'll do a different color. So 1, 2, negative 11, negative 12. That way I can write these in maybe so you can see it. Right? That's what I'm taking it out of there. Because there's still 3 left. They're still in there. Now, what was the next row? What were you given? Negative, what'd you find out? It works. Oh, this is spectacular. Negative 1. So 1, negative 1. 2 minus 1 is not a trick question. Just see if you're paying attention. 1, thank you. Negative 12, and positive. Hey, there it is. It works. And now we are down to x squared. Now, I know I could ask the last row. I know you got another one that works. All right? But I'm not going to worry about that right now because I want to just find both of them. Because let's face it, we still got 2 more. And I want to find them both. So multiplies to be negative 12, adds to be 1. Do such numbers exist? Rational numbers. Close. Somebody had it. I heard one say it right and one say it wrong. It is a 3 and a 4, and then you got to figure out, well, which one's negative, and it's the 4, right? Those are the key numbers. Agreed? No. Come on. You guys got to pay attention. Come on. So it's a negative 3 and a positive 4. Okay. So I'm going to do this kind of longhand. I don't have to, but I'm going to anyways. Minus 3x plus 4x minus 12. Again, when there's a 1 out front, you can kind of go really quick to the zeros, right? And then you got your little squiggle there. We got an x here, x minus 3. X minus 3 also has to be over there then. Can you actually get it? Yes, you can by taking out a 4, and it's a positive 4, correct? So your factors are x plus 4 and x minus 3. Well, how come those don't look like the rest? We got a negative 1, we got a positive 1, then we got all these x's. Because if it has an x in it like that, it's a factor, not a 0. So I want to know when this equals 0. That's pretty good, 0 too. said each one of those equal to 0. So what value of x right there will make that one say 0? Negative 4. And what value, this is the one that that one group already had, what value makes that one say 0? A positive 3. Okay? So the key here, though, is to get to x squared. Don't be happy just sitting here taking stuff out of x to the 4th all day, because you may or may not get anywhere. If those last two were imaginary, you never would have gotten them, unless you kept trying to take things out of what was left over. And that's what I did. We found one. The first group told us it worked. We were left with this x squared down here. And so then we tried to take something out of there to get to x squared. That's the key. If you can do that, you can do this. Remember, I can't really give you the ones that don't have at least some rational answers. Any questions?